9 mainnet shadow forking and 2 public testnets have been merged in the past 3 months. It brought the mainnet merge even closer. If you are considering client's option available for you to run a node, continue listening. Welcome to PEEPanEIP episode 81. I am Pooja Ranjan, and with me is an Ethereum client developer, Mark, also known as a ETH Dreamer in the Web3 world. He's working with the Lighthouse client. About the client, written in Rust, Lighthouse is focused on security and performance. The project is maintained by Sigma Prime. We will learn more about Lighthouse in this episode with Mark. Thank you for joining us.
Hey, Pooja, thanks for having me.
Generally, we request our guests to provide a brief introduction, professional history, or your way to Ethereum community, if you don't mind sharing about yourself.
Yeah, sure. Yeah, so I've been kind of involved since like 2016. I really started looking into Ethereum and sort of slowly developing a passion that grew into an obsession. And then I, at some point, realized that I really wanted to be a client developer, and finally made that a reality in 2021 April. So it's been a little over a year, and I've loved it. So it's just been working on Lighthouse this whole time and really getting completely absorbed in Ethereum. Before I was working in Ethereum, I had a bit of a background in high performance computing and fintech. But yeah, I'm happy to be here, and I'm happy to be in this ecosystem. It's very exciting.
Awesome. That's awesome. I am sure this is cool, and many other people with different background would consider joining the Ethereum ecosystem and contribute to the system.
Yeah, highly recommend if you are.
Absolutely. Well, I understand there is a presentation, so without further ado, let's just peep in.
Great. Yeah. So like we said, I work with Sigma Prime. I work on the Lighthouse client. We've kind of already done the introduction, so I'll skip that a little bit. But yeah, before I talk a little bit about Lighthouse, let's dive into a little bit who Sigma Prime is. So Sigma Prime is the company that develops Lighthouse that I work for. And we were established in 2016, and we really specialize in security auditing and information security. So kind of our whole goal is to improve the security of all layers of this of Ethereum simultaneously. We're one of the few auditing firms that is comfortable working on all layers of the stack. So obviously we work on the base layer with Lighthouse, but we also do things like smart contract auditing and security audits, and we've even worked with layer twos. And so there's a team of about 20 people, and about half of them are that kind of security auditing and review, and the other half are Lighthouse developers. And we work closely with the Ethereum Foundation on spec proposals and changes, and obviously working with Lighthouse. Yeah, so Lighthouse itself, development began in July of 2018. So that's significant. If you know anything about the Ethereum roadmap, you'll know that at one point in time, staking or proof of stake change and sharding were kind of separate tracks, and were proceeding as separate teams, and they were kind of planning on doing these things separately and then doing a bunch of work to unify them later. And I believe it was in March of 2018, they kind of had these teams come together and realize, we could actually get a lot better result if we unified this work together. And so that's what they did. And then in June, they did make that decision that's officially what they were going to do, which was kind of painful. They had to deprecate a lot of work. And then in July, they sort of made the public announcement that that's what they were doing. And that's when Lighthouse development began. So basically, as soon as the Ethereum 2 spec as we know it today had begun, Lighthouse had begun. So Lighthouse, like we said, is written in Rust. Rust is an amazing language. It's extremely performant and memory safe without needing a garbage collector. And it's actually one of the reasons that I had even decided that I wanted to work with Sigma Prime, because I was attracted by Rust. Lighthouse itself, not just because it's written in Rust, but for in general, we're very focused on providing a secure client as we can. In terms of standout features, we have an extremely robust networking layer that we've put a lot of time into. Currently, we're about a third of the network by block proposals, according to Michael Sprawl's block grid, which tries to determine these things. We have about 8 full-time developers, which includes me. So yeah, like I said, we have a really great networking stack. This includes custom peer scoring algorithms. So we have tried to maintain the most valuable set of peers for the node. In ETH2 networking, you have a lot of churning of different peers, and a lot. It's a very dynamic environment, and so you'll have to subscribe to different topics and different sets of peers. And so we try, and you have to do that quite quickly. And so we try to maintain lists of peers that are long-lived at different subnets so that we can quickly get, when we need to quickly get a set of quality peers for a given subnet when we need to subscribe to that subnet. We try to strive for like uniformity across the list, so we're not, being a Sybil attacked or anything like that. And we get really good connectivity across the network. And ultimately, this means improved attestation performance for users because your client is well connected, but also because of our strict peer scoring algorithms, we're pretty hardened against attacks. At least we have made a lot of progress on that front. The networking layer has taken a lot of pains to be multi-threaded so that we're really resource efficient and really responsive. It's modular, so there are a couple of other projects that do use our networking layer, and we continue to develop more features for it. There's EpiSub, which is an improvement on Gossip Sub. I might talk a little bit more about that at the end. And we also have improvements to our discovery protocol as well for topic discovery. To kind of illustrate the point, we had an interesting bug a little while ago, but it did kind of reveal that our peer scoring was working. So this was like an extremely elusive bug. It took us probably a month to find, where it showed up at first as just users kind of missing attestations. And we started to look into it, and we kind of narrowed it down to, okay, this is some kind of peering issue. There's not good connectivity. And then we narrowed it down to a Gossip Sub issue. So Gossip Sub is the protocol that Ethereum 2 clients use to communicate with one another. And what we saw was that Lighthouse peers were banning other Lighthouse peers. And so we knew it was an issue with Lighthouse, but we still weren't sure what ultimately caused it. And we, went down different rabbit holes and did a lot of inspection of the code and instrumenting and gathering metrics. And it really was really hard to figure out. Eventually, we figured out it was caused by one of our dependencies that we had relied on to provide a timing. Turns out that the timer we relied on had broken and it wasn't correctly keeping time. So it wasn't our fault, it was a downstream dependency, but still this was causing Lighthouse to not perform optimally on the network as a good peer should. And then other Lighthouse peers would see that, and they would see that, this peer is not performing very well, and they would ban it. And so the only reason we found this was because Lighthouse is so strict in terms of the peers that it keeps around. And so that was really good because we were able to actually find this bug, and who knows how long this would have taken to find if we didn't have something that was kind of raising that flag for us. But it also kind of speaks to the robustness of our peer scoring. Being a security focused company, we also do a lot of fuzzing. So if you're unfamiliar, fuzzing is this like automated testing technique where you generate like random or invalid or unexpected data and try to provide it as input to functions in order to try to break them and discover bugs, hopefully before those bugs reach production. So yeah, we've been doing this since very early on, since 2019 on just Lighthouse, but this kind of expanded to where we're fuzzing all the clients. We especially heavily focus on fuzzing the state transition functions, because this is really core consensus code that needs to be like bulletproof, because if there's a difference in how different clients process the state transition, you can end up with forks in the chain and kind of like the worst bugs that you can get. So we focus a lot of our effort on that, but we also do ensure as best we can that the clients are conforming to the ETH2 spec. We have multiple fuzzing engines, both random and structural fuzzing. So like random is kind of the simplest fuzzing where you're basically just generating random data, but you can get even more sort of targeted random data when you do structural fuzzing, where you can feed in the information about the data structures that you're generating as input and kind of provide the fuzzer with information about how data is structured within those data structures, so that the data is random, but it looks valid and it isn't caught by a simple check. And then you can try, and then what we do is use Lighthouse for instrumentation, and we see how we can generate like unexpected data structures that can kind of try to get deep into the critical code paths of Lighthouse. And when we detect that, we also send those, we also test the other clients. So it's kind of like using Lighthouse as a way to guide it. And this is kind of all automated, but we do that differential fuzzing on all the clients. And we found quite a lot of bugs. I believe it's upwards of 40 critical bugs that we found through this process. So like I said, our mission is to try to improve the security of the stack as best we can. Yeah, so a little bit of brief overview of the merge, since we're talking, that's what the subject of this is about. So right now we have two chains. We have the beacon chain, or the consensus chain, used to be known as the ETH2 chain. And all that chain does is really come to consensus on what the head of the chain is and who's voting in the chain, but there's really no other information. It doesn't do anything else. So it's not very useful right now, other than in terms of being a proof of stake layer that comes to consensus. The other chain that we've known and loved since 2014 is the execution chain. Used to be called the ETH1 chain. And that includes all the data that you expect from Ethereum, all the contracts, all the code, and all the balances of all the accounts and all of that. And so the goal is, with the merge, simple enough, is to merge them into one chain. Although under the hood, it's not quite one chain. It's kind of a chain with a sneaky chain embedded inside it, with the way that this works. And because of this kind of embedding process, this is why you're going to need to run after the merge, well, and hopefully before the merge, right? You're going to need to be running both an execution and consensus client at the same time in order to be running what is proof of stake Ethereum. Bit of note on terminology: we don't actually call these things staking stuff and transaction stuff. The technical term is beacon blocks on the proof of stake side, and inside we're embedding execution payloads. So basically, like, we're embedding the execution block inside the beacon block, and then the two clients kind of operate in lockstep and they move forward together. Yeah, like this. And you can actually see this if you go ahead and take a look at the Ethereum 2 spec. You'll see that the beacon block bodies now have a field called execution payload. And inside that execution payload is a whole bunch of information about the execution block. And so as long as we're kind of talking about the communication and how the merge happens, I want to take the opportunity to clear up a common misconception about proof of stake, because I don't think anyone's ever made this point before, but due to the way that proof of stake Ethereum is structured, you can actually see this in real time and clear up this misconception. So a lot of people think that because in proof of stake you have a vote, and that's weighted by the amount of stake that you have, that the validators can kind of do whatever they want, that they can change the rules of the consensus if they want, or they can propose invalid state transitions, or they can steal your funds. Those are kind of the same thing, but that's not actually true, and a lot of people get this wrong. You see this tweet here got a lot of attention. I think Vitalik responded to it about how you can vote and change the properties of Ethereum supposedly under proof of stake. That's easy to disprove, because Ethereum doesn't have any on-chain governance. There's simply just no way to change the rules of the protocol on-chain. That doesn't exist. But the second scenario, what about trying to steal your funds, or what about proposing an invalid state transition? That's a little more subtle or nuanced. And it's not just like Bitcoin maxis that get this wrong. It's people that are well-intentioned and generally know a lot. So the person on the right is actually one of the co-founders of Polygon who had gotten this wrong. And in my personal conversations with people, I've talked to people that are generally knowledgeable that have also gotten this wrong. And so I want to clear this up because due to the structure of the merge, you can actually look under the hood and see that this is not the case and see why. And in order to see why, we're going to talk a little bit about block processing and how block processing happens after the merge. So basically you'll have, what'll happen is a beacon block will come in from the network on the beacon chain, or on the consensus side, just as normal. And the consensus side will do a little bit of validation on it. And embedded in that beacon block is going to be the execution payload. Now that's your, that's all the information about how the state changes under the application of this block. The execution side, or the consensus side, doesn't know whether or not that state change is valid, and consequently whether or not the entire block is valid. So it has to ask the execution client, is this execution payload valid? Does it follow the rules of the protocol? I wrote this thing called JSON RPC Snoop that you can stick between the execution client and the consensus client, and you can actually view the communication between the two. And so if you do that, you will actually see this happen in real time. And so on the screen right now, if you're listening, you can see the request going out from the consensus client to the execution engine of saying, hey, I've got a new execution payload here. Can you tell me if this is valid? And the execution client will take a look at it. It might need to do some things, might need to download blocks or whatever in order to validate it, because they'll have to validate it in parent. But it will basically take a look and ensure that that execution payload conforms to the spec and has done everything correctly, that all the code has been executed correctly, that the final state is correct, that and under the rules of the protocol, the only way that you can move funds around is if someone signs a transaction. There's no other way. So that in order to, if someone tried to steal your funds, that would be an invalid state transition, and the execution client would detect that. And so there's kind of two cases here. Either the block is valid or it's not. If the block is valid, the execution client will send back to the consensus client that that's valid. And again, if you're running the snooper between and you're looking at the communication, you'll actually see this. And so like on screen, you can see the message, and you'll see that it has a big valid in it to say this block is valid. And at that point, the consensus client will persist this block. It'll ensure that this block is valid, or it'll say that this block is valid, and it will make it the head of the chain, and it will let the execution client know with a message that says this is now the head of the chain. And again, if you're running the snooper, you can see this happen in real time. Here there's a message saying this is the new head of the chain, and there's a response, an acknowledgement from the execution engine. And sure enough, if you're watching the logs, what you'll see is new blocks will come in, and each time, because blocks are being added onto the chain, the hash at the head of the chain is going to change because new blocks are coming in with a new block hash. And so you can see that in the logs. Now, what happens in case 2 where the block is invalid? Well, in that case, the execution client is going to notice, and it's going to send back a message saying it's invalid. And in our merge testing, we've actually seen this happen because there's been bugs in the block production code before some of the minority clients that haven't been as well tested because almost all the miners are running Geth. So some of the minority clients had small bugs in their block production code, and that resulted in them proposing an invalid block. And sure enough, watching the logs and watching the communication, you would see the execution engine send back an invalid. And if you're watching the logs of the client, you'll see both that a new block will come in, but then the next message about the status will treat the block as if it was empty, as if it never happened, because it was marked invalid. And you'll see that the execution hash did not change. We didn't add that block to the chain, and we're just basically waiting for the next block to be built on, for another block to be built on the old one. And so I bring this up because it's actually kind of interesting with the merge that you can really see this in real time and see why this works. And so to kind of correct the earlier statement, from this checkmatey person. They were saying, that validators are the ones that are doing the validation, but that's not actually true. All the nodes, in order to be participating in Ethereum, every node that runs for support for ADAPT or for Infura or for exchanges, all nodes are going to do all validation of all blocks. It's the same thing as Bitcoin. It's the same reason you can't steal Bitcoin by just, mining a block that gives you all the Bitcoin and then building a really long chain on top of it. It won't matter. The network will just reject it. And so kind of what's the moral of the story here? Please run a node. Even if you're not staking, it's good to be running a node. You'll support the network, and your node will also be validating all of the state changes and ensuring that the real chain is out there. And you'll be able to detect if you're relying on that, whether or not you're on actual Ethereum or something that some validator has tried to get sneaky with. So then after that aside, we'll talk a little bit about the road to the merge. One of the things that came up that's kind of interesting to talk about is optimistic sync. So this kind of came up semi by surprise in Amphora. So it has to do with like a nuance of syncing and how syncing happens. So, if you're already all synced to the head of the chain and you're just proceeding in lockstep, all is well and good. But what happens when, the execution engine isn't synced, or both clients are syncing, but they're behind the head? Well, if they're at different levels, you could have the consensus client wait for the execution client to catch up to it, and then have them both sync ahead and move forward together as they get towards the head. But it's actually much faster if for the consensus client to kind of race ahead and just use the votes of the chain to determine what the head is, and let the execution client know this is what I see in the head, because that allows the execution client to kind of sync in batches and use existing algorithms that the execution clients already have, because this is how they sync on their proof of work. They'll have something that goes ahead and just verifies the proof of work of each block, and then they can kind of back sync in batches. So it sort of leverages the existing code and existing syncing algorithms by doing this optimistic thing. But it was something that required a lot of thought, and eventually we had to come up with a spec for optimistic sync. And that all was work that happened, after Amphora, but before now. And I believe most of the clients, I think all clients have implemented it. And so that enables the execution engines to sync quite quickly. We've obviously been doing a lot of merge testing. We've, like you said in the beginning, we have had 9 shadow forks, including one that was yesterday. And we've merged Ropsten, and we've merged Sepolia. And those have pretty much gone well. There was like a minor issue on Sepolia where it wasn't any issue with Lighthouse at all. It was literally just a configuration issue. If you remember, what happened on Ropsten was the miners jumped a bunch of hash rate on Ropsten and then kind of fast forwarded the chain. And then we had to like override the TTD via the command line. The terminal total difficulty is the difficulty at which the merge is triggered. So they fast forwarded the chain so that we would hit that sooner than we wanted to. So we had to push it back by manually overriding it. And unfortunately, in our scripts, we simply left that manual override in the scripts when we did the Sepolia merge, and that was unintentional. So all we had to do was remove that command line, and Lighthouse merged just fine, but it did cause a little bit of a stir. And then we had, like I said, yesterday, or I would say Wednesday night, we had a merge of mainnet shadow fork 9. This one was a little weird. I think the hash rate on mainnet got a little irregular, or there was something wrong with the TGD prediction code that we use to kind of guess a terminal total difficulty, because usually with these shadow forks, we guess a far future difficulty that's not going to be hit. And then as we get closer to where our predictions get more accurate, like 2 days before, we'll release a new difficulty, and everybody has to like reboot their nodes with the new difficulty. But this difficulty actually triggered much sooner than we were expecting. So like we had some nodes that merged too quickly, and then they had to be resynced. And then, so we pushed the difficulty back, and that still actually merged 8 hours sooner than we were expected. So there's a little bit of chaos there that all had to do with around predicting the terminal difficulty, but this isn't something that is an issue with the mainnet, because we're not going to be trying to get the exact timing right to within, a couple of hours, and we're not going to be giving users just under a week to sync everything and get all up to date. You'll have a lot more time. And then we did sort of discover a small syncing issue in Lighthouse as well. During mainnet Shadow Fork 9, there was an issue where we were being overly strict with our detection of bad chains in ways that, like, we basically had counted networking errors as if we had been syncing an improper chain, and we fixed that bug, and we've deployed that pull request to the Shadow Forks, and things are running fine now. But yeah, just minor things. And it looks like the Graffiti merge will be mid-August. That's the word on the street anyway. So we're looking forward to that. That'll be our kind of first merge of a long-running beacon chain, because Prater has been running for a long time, so we're very excited for that. But in the meantime, we're going to keep running these Shadow Forks. Yeah, so future directions. We're going to Shadow Fork every week until the merge. Unless probably not the week that Graffiti merges, but every other week, just because this keeps giving us more confidence in our code, and we continue to improve our clients. So there's new changes every week that we still want to test the merge underneath. So there's MEV boost testing. So after the merge, stakers will be able to extract minor extracted value from the blocks. So there's an entirely new protocol for that that's different than the way this has happened in a proof of work that's been built from the ground up. So that needs a lot of testing. It's not like that's delaying the merge or anything, but that is happening in parallel. We are improving our logs to try to alert users of potentially bad configurations, so that we log loudly, so that they would notice any issues before the merge would ever happen. And we're improving our docs for users to have merge readiness. I believe it should be really soon here, because we're getting in the final stretch to where users can start to upgrade their nodes to be merge ready, even if we haven't announced the TTD yet. There's a lot of new features in the pipeline. One that's coming very soon is we've just made our fork choice asynchronous. This has helped improve. Basically, this lets us give the execution engine much more time to propose a block. It kind of helps us overlap communication with the execution engine and block processing, so it's a little more efficient. And that's already been merged into unstable, so that'll make its way to the next release, I would imagine. Tree states is something that Michael Sproul has been working on for a long time. It's this interesting way of Merkleizing beacon states, and this allows you to store a lot more beacon states in memory. So this improves our efficiency under reorgs and things like that, and improves our hashing. And it's also just good for, like, when you need to look back at an earlier version of the beacon state. There's certain situations where you do that, so we can maybe eliminate some caches that we have in the code. EIP-4881 deposit snapshot. So that was an EIP I've written. It's nice because when you sync a beacon node, you have to download all the deposit logs since the launch of the deposit contract, and that generally takes upwards of like an hour to 2 hours. So the deposit snapshots are ways where you can utilize the properties of Merkle tree and make this sync in seconds. So that's really nice, because once those are out, basically you can go from nothing to having a beacon client that's fully ready to participate and validate and propose blocks in a matter of a minute. And most of that time is just downloading blocks from the execution engine. So that'd be really cool to be out. Epi sub is an improvement on gossip sub that will let us reduce our bandwidth dramatically. So that we've been working on. There's also improvements to our discovery that will enable us to do topic discovery. That's kind of been in the works for a long time. Michael Sproul has been working on improving our block packing algorithm. He's going to write a blog post about that and the efficiencies that we get. So stay tuned for that. We may at some point build a light client. It's not like we've definitely committed to that, but that's a possibility. And then we're just kind of keeping up with all the changes that all the clients are requiring. I'm sure the day after the merge, the next topic will be when is Shanghai. And so there's just a lot of things happening all the time. So yeah, that's the talk. Thanks for listening. If you're running Lighthouse, please follow StigPIO on Twitter. That way you'll know you're getting the latest updates if there's a new release or something that needs your attention. We also have a Discord you can hop in. I've got the link there. If you want to follow me on Twitter, like I said, I go by ETHDreamer, also on GitHub. Yeah, so open for questions.
Thank you. It was a great talk. Definitely you covered the basics of clients and the common misconception that is really important. Thank you for that.
Yeah, I hadn't seen anyone make that point, and I just thought it was actually kind of nice due to the communication that you can really see this in real time, because this is, it's just as true in Ethereum as it is in other proof of stake implementations, that you can't just do whatever you want. But in other implementations, you'd have to open up the code and take a look at the code. Whereas in Ethereum, because of our separation, you can actually just look at the communication directly and see what happens with an invalid block.
Yeah, the JSON RPC snooper that you talked about, definitely it helps us understand the communication going on and between the blocks. So that's nice. Thank you.
Yeah.
All right. I have got a few more questions that we have collected from the community already. I will try to quickly take some of them. But before that, I'm picking something that you have mentioned in your slides about MEV boost testing. Mm-hmm. Is it something that is to be done on all client level, or is it something that has to be done on Lighthouse level?
It needs to be done in the consensus clients in order for you to extract MEV, but it's not something that is like a delayer for the merge, basically.
Yeah, right.
But it will need to be done in the consensus. All the consensus clients will need to be changed. Will need to have changes to do that. Now, I believe Teku and Prism both already have their MEV boost implementations out. It's under development in Lodestar and Nimbus, and under development in Lighthouse. We have a pull request that you can test, but it hasn't been merged yet. So we're at different stages, but we're all pretty close.
Right. Anyway, this is not a requirement for the merge, so it is fine, right?
Yeah, exactly. Yeah.
All right. So my next question is related to the slashing protection database. Like, among other things, validators are usually concerned about the penalties, and we know that penalty is going to be much higher than what it was in the Altair upgrade, right? So can you maybe talk more about slashing protection database in Lighthouse, and if this hasn't happened already, maybe an imaginary situation where you think running Lighthouse node will help protect a validator from slashing?
Yeah, so yeah, we do have a slashing protection database and slashing protection mechanisms that Michael Sproul has been working a lot on. There's a standardized, he had spearheaded an EIP that standardizes the format so that you can actually hopefully transfer the slashing database from one client to another if you do want to switch clients. I don't know how many clients have implemented it yet, but we certainly have. But yeah, so we have this database, and it ensures that your validator client will never sign a message that could potentially get you slashed. Now, how does it do that? Well, the only way to sign a message that would get you slashed is to conflict with another message that you've previously proposed. So the point of the database is to keep everything you've already signed, and ensure that whatever new message is about to go out, it doesn't conflict with any of those. So not only do we have that, but we've made it as easy as possible to migrate that. So if you're in a situation, a lot of a lot of people become understandably nervous when they need to move their validators. And they're going to need to move to another client. I mean, I've done this on mainnet. You can actually export your slashing database and re-import it later or into your new validator set, so you can ensure that your slashing database goes with you and you still have that protection. That's one of the forms of protection. Another form we have is doppelganger protection, where Lighthouse will basically listen on the network and look for anyone that's signing messages for your validator. Like if you're just about to spin up a new validator, and you enable doppelganger protection, before it starts signing anything, it's just going to watch the network and make sure that nothing else is signing with your keys, because it doesn't want you to get slashed. So that's kind of another form. So because if you're going to migrate your validator, I mean, generally you bring down the old validator, migrate the data over, and bring up the new one and make sure that this other one is offline. But we can actually do that programmatically, so that you don't have some kind of human error where you accidentally have them both running at the same time. That's kind of that's the doppelganger protection, but slashing database is also there in case. And so you kind of have two layers there, like in case there was some issue where you didn't import your slashing database or something like that, you can have this kind of dual protection. So we feel pretty confident that if you're migrating your client, you shouldn't get slashed.
Awesome. That's really good to know. It is important to understand like what features are provided by the client. So
Yeah.
the user can pick their client as per their convenience, and the resources those are available to them.
Yeah, for sure.
Moving on, my next question is about Slasher. Lighthouse seems to have Slasher. Can you talk a little bit more about it? Like how does a Light client help increase profitability as a user? And does every consensus client run Slasher?
So yeah, a slasher, if you run a slasher, you can increase your profitability. I will say that the profits that you stand to gain from a slasher will be very irregular, at least hopefully, because slashings are very rare. So but what running a slasher does is you're actually watching the network, you're watching the messages, and you're looking for any kind of messages that conflict or violate the slashing rules. And then at that point, if you become a validator, if you're proposing a block, you can include that data of a slashable pair of messages into that block, and you will cause that validator to be slashed and removed from the validator set, and you will also be incentivized. You will get a reward for doing that. Now you can actually run the slasher in two modes. There's like an individual mode where only you will keep any data that you find, but there's also an altruistic mode where if you're just trying to provide security to the network, you can run your slasher yourself. But if you find anything, it will actually gossip that over the network. And so any validator that sees that gossip, probably the next block proposer will include that slashing. And I do think the Ethereum Foundation runs some of those. So it's kind of a security model where you just need, it's one event, but obviously best if multiple people run slashers. But yeah, you stand to gain, from doing it, and also you're providing security to the network.
Right. I mean, definitely this is not a good thing to have money from getting it from someone else, but it is required for the security of networks. So yeah, why not?
Right.
All right. My next question is related to Graffiti. Like, I know, it's an interesting feature. I don't know, it is an option, and that I consider it as a meme for the US world. So could you talk about the Graffiti? Like, is there any significance of using it other than the fun part? And is it client specific or a general spec of beacon chain node provider?
Yeah, the Graffiti is like a 32 byte field that is included in any beacon block as part of the spec. So you can put whatever you want in that in those 32 bytes. And the next, like most client implementations have it where you can set your Graffiti, And then the next time you propose a block, like whatever you've set in there will be embedded in your block. This is, yeah, a lot of times it's just kind of for memeing around, just people want to put hi mom or whatever in their blocks, and that can be fun. But you can also do things like POAPs. I believe the default for a lot of clients is the client and client version, which is sometimes useful if you see something happen on the network that's funny. You can see what client it was running. It's almost like, and on testnets, we do that explicitly. We set all the graffitis to the client pairs so that when something goes wrong, we can look just based on the block proposal. We're like, oh, this is a Prism Teku, or like a Prism Geth, or a Teku Lodestar, or Teku Besu or something like that. But yeah, so it has multiple uses. It can be, you can put whatever you want there. So it can be debugging information, it can be client information, it can be POAPs, it can be fun meme stuff. But yeah, I'm pretty sure all the consensus clients will let you change it.
That is cool. I mean, earlier I didn't know that it was being used in the testnets for getting to know for debugging purposes, but this is really interesting that development can be done in a fun way, right?
Yeah.
So,
yeah, exactly.
That is nice. Talking about testnets and knowing the history of Lighthouse, it is a client which was there since the beginning. So obviously you have participated in all the testnet that happened. Would you like to talk about any engineering challenge during this preparation for merge or testing the merge?
For sure. Yeah, I mean, at first, before we kind of had Perry, we were just like, I mean, he was around, but we were in the very early stages, like at Amphora. We were just literally like setting up our laptops next to each other and trying to run, yeah, just one node next to another, and just trying to try out these pairs with a one node testnet. For a while, I had even tried to develop something where you could spin up a multi-client testnet on your local machine to try to test the interop between all the clients. Yeah, most of the challenges around that just have to do with like all the clients are subtly different in the ways that you pass command line flags and spin up the node. And so, and no one developer works on all the clients, so you kind of have to get used to each client if you're trying to do that and build that. So yeah, I mean, big shout out to Perry because he's done such a fantastic job, and can spin up these test nets all day. And now we have these awesome tools like Kurtosis and stuff where it's just like you configure one YAML file, and then you can spin up, whatever kind of network you want with whatever kind of clients you want, whatever pair you want. So it's come a long way, but at first it was all manual. Yeah, it was fun, but it's gotten a lot better.
That's right. Yeah, I remember like Kurtosis is helping a lot, and working on different client combination definitely helped with the increased interoperability, right? We are able to just test a different variation of client combination. Talking about client combination, do you think there is any best client combination for Lighthouse?
There's what I would recommend for the health of the network, but there's not necessarily a best in terms of like best performing. So I would recommend that people give Nethermind and Besu a try. Perhaps Nethermind, if you want to narrow it down to one, because they're not Geth. Like, I love Geth, nothing against Geth, and they're not a fork of Geth either. Not that I have anything against Aragon. I think they're fantastic too. It's just that we, as we know, Geth is currently 80% of the network, and we've done a lot of work on client diversity on the consensus side, but the execution side absolutely needs it. This kind of keeps me up at night. Like, in software, a lot of times people think like do what everybody else is doing and you're kind of safe. It's the opposite with Ethereum. It is actually the opposite. It's not just for the good of the network, but it's for the good of your own profits that you run a minority client. Because if you're on a majority client that has like a bug in the EVM and we end up finalizing an invalid state transition, you can lose up to 70% of your stake, like roughly just calculating it out, before you'll finally start to get validating again. So you definitely want to be running a minority client. Probably, like I would put Nethermind and Besu would be a better, like, I mean, obviously running Aragon is better than running Geth, but Aragon is ultimately a fork of Geth. And so if there's a bug in Geth's EVM implementation, it's very likely that there's also the same bug in Aragon, and you could end up also losing money. So and it's kind of like Nethermind and Besu are criminally underrepresented on the network. So I really encourage people to give that a shot. I think for the average user, I'll probably recommend Nethermind. Myself, I'll be running Besu because they need more usage.
Right. Yeah, I know the client diversity on EL client side is little weird, but my understanding is one of the basic reason may have been the proof of work mining option provided. It wasn't provided by most of the client. Like Aragon does not
Right.
do that, Nethermind does not do that, and that's why Geth has been like always the leader. But I'm hoping with this merge, the numbers, the stats will change, and it will be like more decentralized.
Yeah, me too. Yeah, because I mean, it would just be a catastrophe if we finalize an invalid state transition. So please. There's a really good post from Dankrad on this about run the majority client at your peril. If you Google that, and you'll see what I'm
Right.
talking.
I will add that link here. That is really a good post. I will add the link to the description of this video. So yeah, I have one more question on the feature that you mentioned, for choice async, right? And you mentioned that it would probably provide more time to EL blocks to propose their blocks. Is it because of any specific client combination, or is it for like general?
Yeah, it's for any client combination. So basically, like the execution engines aren't always working a way to ensure that they have a block ready to go. They have to be told ahead of time, hey, I'm about to need to propose a block, so get one ready for me. And that just saves on CPU resources and stuff like that. But they do need to be told ahead of time that they're about to be asked for a block. So that gives them ample time to like start putting one together. The asynchrony of fork choice allows us to like basically be like, as soon as we know we're going to need that, we can send a message to them being like, we're, you know, start working on this. Then we'll continue processing, block processing, and then it's on the order of like several seconds later, which should be plenty of time from before we're like, all right, where's that block that we asked about? And, you know, just giving the client more time is generally better.
That is right. I think I remember listening about this issue on multiple calls, that sometimes your clients are not able to propose a block on time.
Right.
That was an issue. Okay, so we did talk about client diversity, touched on it a little bit. And I know this is not that bad on consensus layer sign, and even the Lighthouse, that is good. I'd be curious to hear your thoughts on client diversity and which user base is your primary target, like who can run the Lighthouse node?
Well, we target everyone, but there are some people that maybe like us a little more, like definitely your security focused person, or your what would you say, Linux users tend to gravitate towards us. And a lot of staking pools do use us as well, but we're, you know, doing everything we can to try to provide the best experience. We're coming out with a UI soon, giving people a nice graphical interface. You know, a while back, it was one of the first things I did was add Windows support so that Windows users could use us without using WSL. Yeah, so we're trying to give the best experience, but right now those are kind of the people that like us.
That's right. I know that these features that you mentioned earlier in your slides about what's coming up with these client, the network share will be increased. already the difference is not much between the majority client holder and the rest of the clients, but I hope that this decreases further.
Yeah, absolutely. Yeah. At this point, it'd be great to see Nimbus and Teku and Lone Star get a little more client share, but it's a lot better than it was.
Right. And I missed talking about EIP-4881. Are you aware of any other client working on the implementation of this proposal? This is an interface level proposal, and hopefully will be done on asynchronous in every client.
Right. Yeah, actually Nimbus has already implemented it. The merge or the pull request for Lighthouse, it's been in the queue for a long time. The problem is it's there's like a lot of changes, and since we have the merge coming up, we've like kind of delayed big changes because we don't want to try to, we don't want to introduce any potential bugs right before the merge. And so like kind of the big pull requests have been a little bit on the back burner, but it's been sitting there for a long time. And so soon it will be in Lighthouse, but it's already in Nimbus, which is really cool. Lodestar has kind of like expressed interest in implementing it. I did a lot of work on the EIP to try to make it like really easy for client implementers. There's like a reference implementation and there's like test cases, so like they can easily verify that their code is correct and that they've done it correctly. So I hope it kind of gets through. I don't know. This is kind of my first foray into like the Ethereum governance process. So I'm new to it. I'll keep proposing, but I'll keep working towards it, but I half suspect that it might just kind of like fly a little under the radar, and we'll just kind of implement it and kind of get more clients on board and just kind of peer pressure people into doing it. Because it's not like this big contentious change. It's a nice feature, and it's a good standard. So
I hope it will be. I haven't gotten a chance to look into it, but definitely I have seen very less proposal on interface side, and that too coming up for consensus layer clients. So I'm hoping that this is going to be a good feature change request, and definitely it will not go unnoticed, and that's why we have this PEEPanEIP series. So in this series we talk about proposals, so maybe we will have you in future sometimes. Right now the proposal seems to be in draft, but when it comes to review or maybe in the last call, definitely we'll try to reach out to you to have an overview of the proposal and let community know what good feature we are adding.
Sure. Yeah, I imagine it would be a pretty quick episode because it's pretty simple, but it is cool. I can talk maybe a little bit about how it came to be. It was actually, I forgot to mention this, but it was during M4 that we had the conversations that eventually led to that proposal. So it's really cool.
Of course, we'll try to have you scheduled for that. Well, thank you so much once again. And okay, my last set of questions are from the community side. The official webpage suggests that project team welcomes community participation, which is obvious because this is an open source project. Is there any bounty program or something similar that you would like to share?
Well, there's the general Ethereum bug bounty. But we don't have one specific for Sigma Prime, but the Ethereum Foundation does provide a bug bounty for you can get up to $250,000 for finding a critical bug in either like the EVM code or a client code and things like that. So, and they have been paid out before. So yeah, especially if you're considered security minded and you want to take a crack at that, we would absolutely welcome it, and you can make some serious cash.
That is true. A lot of bounties, a lot of award for doing all great work here.
Yeah.
All right, it's time to wrap up. Do you have any advice for an Ethereum validator or any message for the Ethereum community in general?
Yeah, I mean, if you can, please run a node, even if you're not validating, and please run minority execution client. Those would be my main messages. And strap in because we're almost ready for the merge. That'll be fun.
Sweet. That's very important, and it's a very sweet message for the community member. Even if they are not participating as a validator, just join as a node operator. Well, Mark, we appreciate you sharing insight on client development work and the merge preparation. Thank you for your time.
Yeah, thank you. Appreciate it.
Lighthouse is moving aggressively on client diversity leaderboard with more network share on the consensus layer. I believe this is a good sign for a healthy decentralized network. We hope today's talk will help users learn about another consensus layer client provided to join the network. If you don't want to miss being a part of this emerging technology, consider running an Ethereum validator node today. And on this note, thank you to everyone watching or listening to this special episode on TheMerge. Should you have any question, leave a comment or reach us at ETHCatHerders Discord. Check out description for links to useful resources and guests Twitter to follow. We'll be back soon with another episode on Know Your Client series. Till then, keep sharing your love with Ethereum cat herders and do not forget to subscribe to the channel. Cheers, everyone.